So kind of over the last week or so, we talked about the differences between linear functions and nonlinear functions. What we have to start talking about now is kind of the borderline between algebra and statistics. And that is pretty much when things aren't perfect, when there's not necessarily an equation for it. So let's take a look at kind of what I'm saying there. What if, I had a graph that's a little bit bigger. If I had this graph, right? Um, and normally what we expect is this, right? We expect something along the lines of this, where we're going to start at some point, and definitively we're going to always have kind of the same rate of change or some sort of pattern, right? So we might have something like this linear that goes kind of straight up like this, or even kind of stuff we were talking about last week, or even as if it was like this, 1, 2, 3, 4, 5, 6, 7, 8. Even with something like this, where it wasn't linear, but it was a curve and it was predictable, right? Like essentially, there was some sort of way we could draw a nice line or a curve between all of them. What we're going to start talking about now is what happens when the data is not like that. What happens? What if the data was like, I don't know, something like this? Now, to say that there's not a pattern there might be true, but there's definitely what we call a correlation. Definitely as x goes up, y, or f of x, it's not a function in this case, y is also going up, right? So if we kind of think about it, there is some line that we could kind of trace through here, right? There is something kind of like this, right? That would split through these points, right? But the tricky part about that is there's a lot of different lines that might kind of fit through these points. Right? Those are not the same lines I drew. That one's a little bit steeper. But there's definitely a trend, right? There's definitely something that we can see that's going on here. Um, Note that this is not a function, right? There's two answers here, and there's two answers here. This fails the vertical line test. But if we make an approximation, right, we said, all right, well, that's generally the trend. First of all, it's useful because we can make predictions now too, right? We can say, well, what happens at 1, 2, 3, 4, 5, 6, 7? We could say, generally speaking, at 7, we expect the answer to be 10, right? Like it should be in this neighborhood over here. So what this does is, generally speaking, if you go and you take a sample, right, you go out and you ask a bunch of people questions, how many electronic devices do you have in your house? And you can ask some questions like that. You can group all that data. Now it's got to be bivariate data, so that was kind of a poor example, but we'll talk about that kind of as we go through it. Really, what I want to talk about today, whether or not there is a correlation and the types of predictions we can make. Okay, so let's first talk about no correlation. So no correlation means that you can't tell any trend from the data, right? So if I said here is your data points for whatever thing you put out there, there is no correlation, okay? And we'll talk about it. We'll have a number that represents that. The number will be 0. There is no correlation, right? I could draw a line through this, but it doesn't really say anything for it, okay? Now let's talk about a weak correlation. Okay, a weak correlation might be something that looks, like this, right? Where there is a general trend, right? Like I can kind of draw a line through these points, right? But you see there is some kind of significant distances between these points in the line, right? We're kind of taking a big jump there to go ahead and say something like that, okay? A strong correlation, okay, is exactly kind of like what you think about it, okay? If that was a weak correlation, a strong correlation, you'd have a nice cluster that almost makes a line, right? So a strong correlation, erase this. A strong correlation might be something like this, Right? There is a very strong correlation, right? There's a very tight cluster of points that I could very much draw a line through and pretty definitively make some conclusions about, right? So those are your three types. All of these can be positive or they can be negative. Okay, so if we talked about this, what's a strong positive? This is a strong positive correlation because the line is going up. Okay, a negative correlation would be the same thing, right? So if I said negative correlation, would be the same thing. And negative correlation can be weak or strong as well. But essentially what it says is that as one piece of data goes up, the other one's going to go down. So this would be a strong negative correlation, right? This would be a weak negative correlation, right? It's going down, but some of those points are really far out there, okay? So essentially all you're going to have to do today is tell whether there is a correlation or there's not a correlation, and if it's positive or negative. The next batch of questions, and I'll just zip over to iExcel for a second. I was trying to get you guys a better picture. Interpret scatter plots. Let's go ahead and give this to you guys right now. Okay. Again, a question like this: is there a positive trend or a negative trend? Well, it looks like it's going down, right? So we would say it's a negative trend. Right here, generally speaking, it looks like it's going up, and there's a positive trend. Okay. Here, no trend, right? That's just dots on the board. Okay. Here, I would say no trend. Okay. But again, let's talk about some of the other things they might ask you. Make a better prediction for y when x is equal to -5. Well, if we kind of look at this, well, here's x is equal to -5, right? We can kind of expect that the line should kind of trace somewhere through here, right? Like your answer should be in here. So hold on, let's take a snip of this real quick. Kind of show you guys what I mean. So if they give you some data like this, and you were to draw a line through it, again, it's not going to be a perfect thing, right? But we could expect that at 5, it should be hovering somewhere in between kind of 4 and 6 up there, right? So when we go back here, if you take a look, yeah, it's 4 in between 4 and 6 is 5. They're good enough to give you answers that one is totally in here and the other one would be well out here. So what's the prediction for y? Well, the better prediction for y would be 5. Okay, so you guys can have at that again for x equals 25. So 25 would be in here somewhere. So we would expect it to be in here. I would say there's much likely 42 or 90. Well, I'm going to go ahead and I'm going to say 42. Okay, so give those a try today. We'll go over some more specific details tomorrow, the numbers associated with it, and some more advanced problems. Okay, good luck, guys.